In Lesson 29, we'll be working more with exponents, in particular negative exponents and zero exponents. Now, we've been working with positive exponents, and you know, like a problem like this, 3 squared, that's the same thing as saying 3 times 3. Well, what is 3 to the negative 2? What does that mean? Well, just like 3 squared, we know that's a definition. We've defined that to mean 3 times 3. Well, 3 to the negative 2 power, that's the same thing as 1 over 3 squared, which is going to be 1 over 3 times 3, or 1 over 9. So there's not really any other understanding to negative exponents except for that definition. You just have to know the definition. When you have a negative exponent, you can make it positive by taking the reciprocal of the number, or the base, and then changing the sign of the exponent. And a way to talk about this just with variables, 3 to the minus 2 is equal to 1 over 3 squared, in the same way that x to the minus n is equal to 1 over x to the positive n. So memorize that definition, because you'll be working with a lot of negative exponents from now on. Let's go ahead and simplify some expressions here. All these will have negative exponents in them. So the way we simplify those and just get an answer without any exponents at all, that's what we want to do when we simplify, is we need to take the reciprocal of the base part of that and then change the sign of the exponent. So look at A. We have a negative 4 there, so we need to write that 1 over negative 4, and then that will be to the positive 3 power. And so that would simplify to a negative 1/64. Then look at B, 1 over 2 to the negative 3rd. Well, if we want to simplify that, we just need to take the 2 and move that up. Take the reciprocal, so we have 1/2 there. So we make that a 2 to the positive 3rd, which will equal 8. In C, we have 2 to the negative 4. If we want to simplify that, we would do 1 over 2 to the positive 4. And so that would just be equal to 1/16. And then in in D, we have 1 over negative 3 to the negative 2 power. To simplify that, we bring the negative 3 up and then change the sign of that exponent to squared. Negative 3 times negative 3 would be a 9, positive 9. Now another relationship you might want to write down, it's the same idea here, is that if you had 1 over x to the minus n, that equals x to the positive n. So, I mean, we did some problems that dealt with that, like in B and in D. It's the same idea as that rule that I have circled in red there, except you just change the sign of the n's. That's all we did different. So remember that rule for negative exponents. Practice some more if you need to. There's practice problems in the lesson that you can do as well, and make sure you understand that. Now, part B of this lesson is about zero exponents, and that means an exponent of 0, like if you had x to the 0. Now, x can be considered a variable, so we could put all kinds of different things in there. A 1, a 10, a negative 1,000, just whatever. That's why it's called a variable, because the number that you substitute in for it is variable. So basically what you could say here is anything raised to the power of 0 equals 1. And that's a definition. You can explain that definition, and you can do that by just looking at this problem right here. X to the 1 over x to the power of 1. Now for that relationship there, as long as x is a non-zero real number, that is equal to 1. Now, we just went over the negative exponent rule, so let's move that x to the 1 that's in the denominator there, let's move that to the numerator, and we would have x to the 1 times x to the minus 1. And then we can use our product rule for exponents, and we'd add those two exponents together, and we would get x to the 0. And so we just said that that is equal to 1, so we just basically proved why x to the 0 is equal to 1. So anything raised to the power of 0 is equal to 1. Now you'll be able to use that to simplify some expressions, and that's what you'll be doing next. Now look at practice problems E and F. One of those, the answer is negative 1, and the other is positive 1. Which one do you think the answer is negative 1 to? Well, it would be E, because in that one we're just saying that that whole quantity, 5 to the 0, we just look at that first and simplify it. Anything to the power of 0 is 1. There's that negative out front, so we'd say negative 1. Now in F, we're saying negative 5 to the power of 0. And so for that, the answer would be positive 1. Anything to the power of 0 is equal to 1. Look at practice problem G. Simplify that. X plus 9 plus py 5, all of that to the power of 0. Well, anything raised to the power of 0, all of that is included in parentheses to the power of 0, so it would just simplify to 1. Let's do one more problem. I want you to expand that relationship there. So let's just go ahead and do that, and we'll take that 3x squared y to the minus 2, multiply it by 2y squared first. I'll just write out the solution up here above the problem. 3x squared y to the minus 2, and then multiplied by 2y squared plus 3x squared y to the minus 2, and then times a negative x to the minus 2 y to the 5th. Now I'll go ahead and simplify that relationship. In that first term there, I can multiply the 3 and the 2 together to get 6, and then I have the x squared, and then I have a y to the minus 2 and a y to the positive 2. Well, that's just going to be y to the 0, which is equal to 1. So I don't need to write the 1 on there. And so that first term simplifies to 6x squared. Now the second term, I have a negative sign in that second factor there. And so let's move that to the front, and I'll have negative 3. And then I have x squared and x to the minus 2. Well, again, I'll get a 0 for an exponent there. And the x will, to the 0, that's just equal to 1, so I don't need to write anything. And then I'll have y to the negative 2 plus 5 is 3. And so this simplified to 6x squared minus 3y to the 3rd. Most important thing in this lesson is to understand that definition of a negative exponent. 1 over x to the n is equal to x to the minus n. Make sure you get that down. Okay, well that's all for lesson 29.